Hello guys, I'm Halukosha. Welcome to my math tutorial class on indices and sort. Okay guys, in today's session we shall be taking a look at IGCSE exam style question, additional math 0606. Okay, so you can see that this is actually paper 2-1, question 5, November 2013. So let's get started with the very first question guys. Solve the simultaneous equations. 4 raised power x divided by 256 raised power y equals to 1024. And the second equation is 3 raised power 2x times 9 raised power y equals to 243. So we have to solve the system of equations simultaneously. So this is like initial equation, guys. Okay. So let's work on the very first equation. This is very one here. So I'm going to express everything as power of that this base right. Make all the base to be 4. So 4 raised power everything, something like that. So hope you know how to break 256 down. You can just go ahead and use reduce it to the I want to use maybe as a product of prime factor, something like that. So even though 4 is not a prime number, but I'll use 4k. So 256. I'm not going to do this. I just want to show you something. I'll use my calculator to complete it. 256. Okay, so use 4 to break it down. Okay, use it 4 to break it down, something like that. So something like that. So let me just because I'm not going to waste much time. So 4 raised power what will give you 256? That should be 4 raised power. Let me use my calculator now. 4 raised power 5 or 6. Let me see. 4 raised power 5. 4 raised power 5 is 1024. Okay, so 4 raised power 4 is 256. So 256 is same thing as 4 raised power 4. Okay, so 4 raised to the power of 4, that is 256. Then y. Okay, hope that is clear. Equals to your 1024 is actually 4 raised power 5. So 4 raised power 5 will give you 1024. Hope that is cool. Hope that is cool, guys. Okay, now so use law of indices now. Yeah. So when it's the same and divide, it means I should take away the exponent. So this one simplify into 4 raised power x. Then 6 is divided by, so that will be minus 4 raised power y. Okay, so this equals to 4 raised power 5. Nice. Okay, so you can see now that the base are the same for the left hand side and the right hand side, so you can take that off. So the very first equation I have here is now x minus 4y equals to 5. So that is my very first equation. So I'm going to type this one equation 1. Okay, so let me work on the second initial equation and reduce it to linear equation. So this one here, I'm going to express everything as the base will be 3. So 3 raised power something. So I have 3 raised power 2x. 3 raised power 2x. Let me just put this one in a rectangular box because I'm going to solve the system of equations simultaneously. Okay. So this is the very first equation. So let me reduce the second initial equation to linear equation. Okay, so this one 3 raised power 2x times, and 9 is the same thing as 3 raised power 2. So 3 raised power 2 is 9, so that's 3 raised power 2y. Okay, I'm working on this one, guys. Okay, equals to 243. So 243 is this 3 raised power 5. Okay, so 3 raised power 5 is 243, don't forget. So using law of indices, when you have multiplication, then you just go ahead and sum the power, okay, or exponent. Okay, so that's 3 raised power 2x plus 2 raised power y. Okay, so that equals 3 raised power 5. So you can see that the base on the left hand side and the right hand side are common, so you can cancel out, and you now have 2x plus 2y equals to 5. So this is equation 2. Okay, so what I'm going to do now, I'll go ahead and solve this the two linear equations, or better still the system of linear equations simultaneously. Okay, so this is equation 2, so solve equation 1 and equation 2 simultaneously. I may need to demarcate my board. Okay, so now the very first equation I have here is x minus 4y equals to 5. I don't know why am I writing my x like that. Okay, sorry about that. X minus 4y equals 5, and that is very first equation. And the second equation is 2x plus 2y equals 5. For some reason, how come how come both equals 5? Okay, that is interesting, right? Yeah, cool. So this is equation 1. The right hand side for the equation is 5 for some reason. Okay, this is equation 2. So now I'm going to use the elimination method. Okay, so the best thing for me now is to go ahead and multiply equation 1 by 1, and I'll multiply equation 2 by 2. Y, such that I can have 4y here, then I can sum the two stuff. So now the result equation will now be, let me just start the result equation, equation A and B. So 4y equals to 5. So because I multiply by 1, so 1 is a multiplicative identity, so it's not going to affect the equation. So let me type this one equation A. Okay, and the result equation here is now 2 times 2 is 4. That is 4x plus 2y. Okay, equals 10. Equals 10, right? Okay, so yeah, pretty cool. So let's start this one equation B. Okay, so let's solve the system of equations simultaneously now. Okay, so now what I'm going to do now is I'll just go ahead and sum equation 1 and 2, and so if sum equation 1 and 2, I'll be able to eliminate variable y, so I can solve for x. So to solve for x, solve equation A and B. So the result equation is 5x equals to 15. So therefore x equals to 15 divided by 5, and that is 3. So the value of x is 3. So let me put that one in the rectangular box too. So we're going to substitute for the value of x in equation, let's go for equation 1. So put x equals to 3 in equation 1, then there 1. Put, okay, x equals 3 in equation 1. Okay, so to solve for y. So this is equation 1. So what do we have there? So I have x minus 4y, and x is 3. So that will be 3 minus 4y, okay, equals 5, right? So minus 4y equals 5 minus 3, and that is 2. Therefore, y equals to minus 1 over 2. So that will be 2 divided by minus 4, that is minus 1. So the value of x and y that satisfy this initial equation are what? X equals to 3 and y equals to minus 1. Okay guys, that's the end of the first question, guys. Let's go to the next question. Guys, here is the next question. Solve 2 raised power x squared minus 5x equals to 1 over 64. That is inverse of 64, guys. Okay, let's go ahead and demarcate the board. Yeah, so what I have here now is 2 raised power x. So what I'm going to do is just I'm going to express this prime factor. Okay, so just express 64 as a product of 1 factor. Okay, that is this. Okay, so I have 2 raised power x squared minus 5x equals to 64 is same thing as 64 raised power minus 1. Don't forget. Yeah, inverse. It was 1 over 64 is inverse of 64. Okay, so now express it first as a product of prime factor. That will be 2 raised power what? That is 2 raised power, let me check, 2 raised power 5, 6. That should be 2 raised power 6. So 2 raised power 6, that should give me 64, right? Correct. Okay, so now I have 2 raised power x squared minus 5x. That is 2 raised power x squared minus 5x altogether, right? Equals to, this is 2 raised power minus 6. Okay, that's the same thing. 64 raised power minus 7 because 64 is 2 raised power 6. Okay, now the base, if you look at the base on the left hand side and the right hand side, common, so 2 is common, so it can cancel out. So the resulting linear equation is x squared minus 5x. Then if you bring minus 6 back, that will become plus 6. If you take minus 6 from the right hand side to the left hand side, that will be plus 6 equals to 0. So this is what? This is a trinomial. Okay, actually quadratic equation. Trinomial because it's 3 terms. Quadratic because the highest power is 2. Okay, so let's just go ahead and factorize this one here. So go ahead with your shortcut, guys. You guys are good with factorization, I know. Okay, so I break this one down, and this should give me 3, and minus 3 minus 2 should give me plus 6, minus 3 minus 2 should give me plus 5. So yeah, if you factorize x squared minus 5x plus 6, that should give you x minus 2. You can take it either way, whether x minus 2 into x minus 3, or better still x minus 3 into x minus 2 equals 0. So from here now, value of x equals to 2, or this question seems to be quite simple, right? Okay, I suppose it's 3. So these two, these are the value of x that satisfy this simultaneous equation. So that's the end of the question. This is for maths. How come I could solve it so easy? Pretty cool, so easy that. Okay guys, here is the next question. Integers a and b are such that a plus 3 root 5 all square plus a minus b root 5 equals to 51. Find the possible value of a and the corresponding value of b. Okay, this is quite cool, right? This question is not funny. Okay guys, if you look at this question very well, this is more of solving the equation involving solve. Okay, so let's take a look at. We have a irrational part and we have rational. Okay, so what we're going to do to complete this kind of question, if you see this type of question, and the first thing is for you to let me just put this in a rectangular box. Just separate, just take this side to the right hand side. Okay, so let me just take that off. Okay, so yeah, let's just get started. So I have a plus 3 root 5. Okay, don't forget that 3 root 5, that is irrational. Okay, irrational number. Okay, all square equals 51. So 51 is on the right hand side already. So move these two also to the right hand side. So this is plus a, so that becomes minus a. Then this is minus b root 5, so that will be plus a square root of 5. Okay, so we can continue from here. So we go ahead and expand this one here. So we'll let me just do that. Okay, so you have a plus 3 root 5 into a plus 3 root 5, okay, into a plus 3 root 5. The only thing is that we not waste much time with this. I know you guys know how to expand given expression. This is actually a polynomial expression 2 times, so quite easy, right? So equals to 51 minus a. Now this 51 minus a is irrational, okay? So you can separate the rational from the rational term from the irrational term. So b root 5 is irrational term, okay? So I'm able to separate the right hand side. So let's go ahead and complete this left hand side. So this will give a square plus, okay, so this will be a plus, sorry, 3a root 5, then 3a root 5, so that will be 6a root 5. 6a, sorry about that. So this will be 6a square root of 5. Okay, so then you have 3 root 5 times 3 root 5, so that will be 3 root 5 squared. So that's something like 9 times 5. So 9 times 5 is 45, right? 9 times 5 is 45. So that will be plus 45. So that will be plus 3 root 5 all squared. So if you do 3 root 5 all squared, that should give you 45. Okay. Yeah, pretty cool. Not a bad deal. Okay, so I need to write something more. I need to finish this question very fast for some reason. Okay, but it's not a bad deal, so let's just go ahead. Yeah, let's just follow step by step. Okay. Okay, now this time around, now I want to bring all the rational terms together. So that is a squared plus 45. So bring all the rational terms together. That is, I'm trying to separate the rational term from the irrational term plus 6a root 5. Because of that root 5, that is irrational term. 6a root 5. Okay, this is pretty cool now. So it was 5. And if you observant, you notice that I actually put all my rational term in in brackets. Okay, so what we are going to do now, we're going to form system of linear equation, okay, such that you equate the rational term. Let me put that in a rectangular box. So to complete that, you just equate this one here. Sorry about that. So equate the rational term, that is, why is that? What's going on there? I just want to take, sorry, I don't know. Let me just use this one then, I don't know, for some reason. I want to take this and it's not allowing me. Okay, I want to equate the rational side. So I'm going to equate these two, then equate the rational terms too. Equate the rational terms too. So that will be a squared plus 45. Okay, so the rational terms on the left hand side equals to the rational term on the right hand side, 51 minus a. And I'm going to do the same thing for a rational term. Okay, so similarly, okay, I don't know whether I should just complete this one. I'll just make similarly. Yeah, let me just go ahead. Similarly, the rational term, but this one I'll put in rectangular box because I'm not going to work with it now. I suppose maybe because I have two variables. I have a and b, so I'm not sure I can complete that. So it's better to work with the first, rational term. So let me just put this one in. This is this second equation. Can I just type this one equation 2? Yeah. Let's just type this equation 2, and this is my equation 1. But that is not an equation yet. Okay. This is a good. This is an equation already. Okay. So this is equation 2. Okay. So now let me work with this rational term now. This one here. So just bring all everything together. Okay. A square plus a, that is minus a. Move down here. That will be plus a. Then you have 45 minus 51. 45 minus 51, and that is minus 6 equals to 0. So it's from the rational term side. I've been able to get this trinomial. It's actually quadratic. This is equation 2. This is actually quadratic equation. Okay, so you can solve. Just factorize this. That will give me a. This should be 3 2 minus. Okay, so that will be a plus 3. Okay, just factorize a squared plus a minus 6 into a minus 2. So if you expand a plus 3a minus 2, and that should give you the trinomial you have up there. Okay, that is a squared plus a minus equals to 0. So from here now, a equals to 2, or a equals to minus 3. Okay, now when a equals to 2, yeah, let's put that. So when a equals to 2, I don't need to write English. I've been writing too much. Let me just put this in regular because I need to manage this space very well. So I'll just put this one something here. Okay, then I'll put something here also. I think I should be able to complete that in that. So when a equals to 2, and this equation b here now. Okay, yeah, another thing here is this. You can see that this is root 5, so root 5 can cancel out root 5, such that we have b equals to 6a, or better say 6a equals to b. So when, I don't need to write a word guide, I don't know, I'm just, when a equals to 2, yeah, when a equals to 2, okay, just then b equals to 6a. From here, b equals to 60, that is 60 to 2. 60 to 2. So that will be what? B implies, that implies b equals to 2. That implies b equals to 2. Okay, sorry about that. I just need to manage the space around it. Similarly, when a equals to minus 3, then b equals to 6a. So b equals to 6 into minus 3. By implication, b equals to minus 18 implies, let me just write it, sorry about that, b equals to minus 18. Okay, so now so we have to find the possible value of a and corresponding value of b. So the set of solution for a and b, a comma b, let's write the set of solution to be such that, so when a is 2, Then we have 12, b is 12. That's it in coordinate form there. Okay. Then when a equals to minus 3, then b equals to minus 18. So that's set of the solution. Okay guys, this is pretty cool. Okay, this here is the next question. For some reason, why do not use the calculator in this question? Okay, so yeah, I expected not to use calculator to complete this very task. Okay, so let's go ahead with the question. The diagram shows two parallelograms. Sorry about that. The diagrams show two parallelograms that are similar. The base and the height in centimeter of each parallelogram is shown. Given that x, the height of the smaller parallelogram, given that x, the height of the smaller parallelogram, is p plus q root 3 over 6. Find the value of each of the integers p and q. Okay, guys, we need to find the value of the integers p and q. Okay, so yeah, given that the height x is x, so we have to solve for x first. Then we now compare to this solution to this. Then we go ahead and find the value of p and q. Okay, yeah, guys, the first thing you need to note here is that these are actually similar parallelogram. So we're going to complete this very task using similarity rules. Okay, so let's go with similarity. Okay, so yeah, in similarity, yeah, there is something you guys need to know. So you compare the corresponding side in similarity. So meaning that this side correspond to this side. Okay, so then let me change the color now to blue. Okay, similarly this side correspond to this side. So now you can use the big plane shape divided by small plane shape, or better say small over big, either way, just like we want to find that is in transformation, right? Like you want to find what do you call that, scale factor, something like scale factor. Okay, yeah, so let's go ahead now. So similarity, so I can start with this. Let's compare the blue first. This blues, yeah, blues. Okay, 6 plus 2 root 3, that is the side of the base for the big parallelogram, divided by the base of the small parallelogram, is proportional. So you can just say equals to, guys. Okay, equals to, it's like directly proportional. So equals to, yeah, since I use big here, so you go back to the big now. So the height of the big parallelogram, okay, divided by the height of the small parallelogram. Guys, don't make mistake and put this one now. Solve for x first, so you now compare your answer. So the task I have here is just to solve for x. Okay, so I'll now compare my final answer with this. Okay, so let's go ahead and do that. So go ahead and cross multiply. So if I cross multiply now, then x will give me something like this, because I want to be able to manage my board. So cross multiply this, multiply this, so I will have 1 plus 3 root 3, okay, into, so let me just put it like this. Okay, let me just put it like this. So into, so you cross multiply this, multiply by this, 5 minus root 3. Okay, so now don't forget that this multiply x, so I want to find x, to divide both sides by this one here. So that's 6 plus 2 root 3. Okay guys, if you look at the denominator is a surd. Okay, so we can't leave it like that, so you go ahead and do what? Rationalize. Guys, hope you know how to rationalize. So you multiply both denominator, multiply both sides by 1 into everything, so that is 5 minus, guys, I just need to manage my board, so I will need not to write everything, guys. Hope you understand, right? 1 into everything plus 3 root 3 into everything. You know how to open this one up, guys. So 3 times 5 is 15. That's 15 root 3. 15 root 3. Okay. That is then minus 3 times 3, because root 3 times root 3 is 3. So 3 times 3, that is 9. So minus 9. Oh, that is pretty good, guys. Okay, then divided by 6 plus 2 root 3. Okay, so guys, go ahead and rationalize now. So to complete that, you just multiply with the conjugate of 6 plus 2 root 3. So what's conjugate of 6 plus 2 root 3? That would be 6 minus 2 root 3. 6 minus 2 root 3. So guys, don't forget, I hope you know how to rationalize. You guys are Add Maths students, so I hope you're familiar with this. Okay, how to rationalize. Just go ahead with the conjugates. Okay, if this one to be minus, then this will be conjugate will be plus, something like that. Okay, so yeah, let's open up this one now. Yeah, definitely this one will just give you difference of square. That will be 6 square minus 2 root 3 all square. But for this one now, we need to take our time. Let's just work with this first. 5 minus 9. Let's work with this first. 5 minus 9. So that gives what? So 5 minus 9, that is minus 4, right? Am I correct? Minus 4. Okay, then also this is 15 root 3 minus root 3. This is like 1 root 3. So that will be 14 root 3. I have 14 root 3. Okay. Then minus 9 plus 5, that is minus 4. Okay. Divided by. Now this one will give me 6 squared minus 2 root 3 squared. Do you want me to write everything because there will be no time? So that should give us 36 minus 36. Let me use my calculator. 36 minus 2 root 3 all squared equals to, that is 24. So that's 24. Okay, so this gives 24. If you go ahead and open up that should give you 24. Okay, guys, now what we have to do here now is this one here I'm not through. Okay, sorry about that. So that this is when you work with this, you have 14 minus 14 root 3 minus 4, so into 6 minus 2 root 3. So I need to go ahead and open this one up now. Okay, so this should be for all. Sorry about that. So I can bring my 24 midway. So just centralize it, okay? That is middle align. Okay, so middle align. Okay, so just take that middle align now. I see it. Okay, so yeah, 24. So now open up this one now because of space. I'll just 14 root 3 times this. 14 root 3 times 6. So what is 14 times 6? So let me just start with that. Let me just show you this. So I'm going to have 6 into, I want to open up everything. 14 root 3. Okay, then minus 4. 43 minus 4. Then minus 2 root 3 into 14 root 3 minus 4. Okay, so this is a very pretty way or expanding this kind of stuff. But better still, what I did is 16 in 6 into everything, then minus root 3 into everything. But better still, 14 root 3 into this, then minus 4 into 6, something like that. Guys, you know how to expand, so I don't need to waste much time. Okay, 24. So at this time around now, I'll just go ahead and complete my calculator. So now you use this one to open up this one now. So you have 6 times 14 root 3. So what is 6 times 14? That is 84. So that is 84 root 3. 84, hope I'll be able to manage my board very well. Okay, 84 root 3 minus 6 times 4. 6 times 4. That is 24. Okay, minus 24. Then use 2 root 3 times 14. So 2 times 14, that is minus 28. Okay, yeah, this is minus 20, then root 3 times root 3, that is 3. Okay, so you have a minus 28 times 3. Okay, so minus 28 times 3, that is 84 again. That is interesting. So this one is 84. Okay, so 84, that is 2 root 3 times 14 root 3, that is 84, plus, this will give me 8 root 3, okay, 2 times 4 is 8, 8 root 3. Okay, divided by 24, all divided by 24. Okay, so the best thing now is to factor out, but before I factor out, let me just combine now. This is 8 plus 84, so what is that? 8 plus 84, that is 92. So that is 92 root 3. So just copy this one first, this one here, and this one here. Okay, so that is 92 root 3, 84 plus 8, that is 92. So I have 92 root 3. That's 92 root 3. Sorry about that. Then minus 24 minus 84. That is what? 84 plus 24. That is minus 108. Minus 108. Okay, I don't like that. Minus 108, right? 08. Divided by 24. So now what I want to do now, I want the denominator to be 6. So divide anything you do to the denominator, go ahead and do the numerator too. So 24 divided by 6 is what? 4. So you divide both denominator and numerator by 4. So 4 here, that will give me 6. Okay, so 4 is 92. 92 divided by 4, that is 23. So 23. Sorry about that. 23. So this is 23. Root 3. Then 108 divided by 4 minus. So what is 108 divided by 4? So use 4 to reduce the denominator and numerator. That is minus 27. So we compare the solution value for x here, 23 root 3 minus 27 divided by 6. We compare with the height of the smaller parallelogram, which is p plus q root 3. Okay, you can see that the denominator is 6. So therefore the value of p will be what? P will be minus 27 and q will be 23. So I can just complete that here now because sorry about that. I couldn't manage my board well today, right, for this equation. So now P is what? P equals to minus 27 and Q is 23. See, 23 over 3. Q over 3. So Q is 23. Okay guys, this is the end of this question guys. Let's go to the next question guys. Here is the next question. Okay, let me just go ahead and evacuate the board. I think it's necessary. This 3 marks, right? Okay, so let's go ahead. Given that p raised to power minus 2, q r raised to power minus r, all divided by square root of p raised to power 1 over 3 q squared r raised to power minus 3 equals to p raised to power a, q raised to power b, r raised to power c. Find the value of a, b, c. Okay, so guys, let's go ahead and find a, b, c. Yeah, let's just go ahead and demarcate this also. Okay, so let's just separate the question from the solution. Okay, so now here, what I have here now, the first thing I'm going to do is to work with this square root here. So let's go ahead with the numerator first. So that is p raised to power minus 2 This is same thing as q raised to power 1. Don't forget q raised to power 1. I'm just writing it like that because there's no power, so just go ahead and do that. Then r raised to power minus half. Okay, so now I'm going to remove the square root. So by implication, that will be raised to the power of half. Okay, because the square root of a means a raised to power half. Okay, guys. Okay, now so I'll put all this in brackets. So I have p raised to power 1 over 3. Okay, and this is q squared. Okay, then r raised to power minus 3. Then square root means that by implication, square root means that all raised to power half. Okay, so square root means all raised to power half. If it was the cube root, that would be all raised to power 1 over 3. First root all raised to power 1 over 4, something like that. Okay, so now I can go ahead and use half to open up the brackets now. So what do you have there? I have a p raised to power minus 2, q raised to power 1. I just need to write the power, the index for all, okay, such as to apply my laws of indices, right? So now p. Now this is 1 over 3 times half, that is 1 over 6. Okay, then q squared. So this is 2 times half, so that is raised to power 1. Okay, then r minus 3 times half, that is minus 3 over 2. Hope that is pretty cool, guys. Okay, so let's go ahead with laws of indices. So we work with the p first. So now this is p raised to power minus 2 divided by p raised to power 1 over 6. So that will be p raised to power minus 2 minus 1 over 6. Okay, so for the p now, the index now is minus 2 minus 1 over 6. So you can use your calculator to complete that. Sorry about that. Then q raised to power 1, then minus 1, so that will be q raised to power 0. Then for r, I have a minus 1 over 2, then minus, division is minus, then minus 3 over 2. Hope that is pretty cool, guys. So you can go ahead and pick up a calculator, guys, and do minus 2 minus 1 over 6. So that gives what? That's minus 13 over 6. So that is p raised to the power of minus 13 over 6. Okay, guys, don't forget I'm just working on the left hand side, so we go to the right hand side and see what a, b, c are. Okay, yeah, for some reason I don't know, just put minus 10. Okay, so that's for p. Then q, 1 minus 1 is what? 0. So that is q raised to the power of 0. Then r, then I need to use calculator here also. So minus half, minus 3 over 2 is plus. So minus half plus 3 over 2, I think that should give me 1, but let me confirm. Okay, so minus 1 over 2 plus 3 over 2. Guys, just go ahead and use calculator. You don't need to. Okay, that is 1. So yeah, confirm. Okay, then equals to the right hand side. What do we have on the right hand side? P raised to the power of a. Okay, then q raised to the power of b, and we have r raised to the power of c. Sorry about my handwriting. So you can compare a, b, c. So a is what? So a is, compare common base b, and here is b. So compare the index for b. So a is what? Minus 13 divided by 6. Minus 13 over 6. And compare the index for q. So q, that is b, the index b equals 0. And finally compare the index for r, c equals 1. Okay, let's just go ahead and put in rectangular box. So therefore the solution to that question is such that a equals minus 10 over 6, and b equals 0, and c equals 1. That is pretty cool. Let's go to the next question.
There are quite good numbers of maths, additional maths, ICT, robotics and coding videos on my YouTube channel that will help you guys enhance your learning. If you find any of my resources and contents useful and cool enough, just go ahead and click like. Also, do well to hit the red button to subscribe to my channel for auto update of subsequent videos. It's free. Love you guys. Do have a great day ahead. Now, let's end with this note.
Break the streets.